It's David Spears, Civil Engineering Instructor at Texas Tech University, talking about statics, CE 2301. We've got a 2D rigid body equilibrium problem to look at today. When you see that on the test or when you see it on the homework, I want you to remember these three steps that I've written up here in blue. And they are that I need first a free body diagram, and then I need to get everything in Cartesian form, and then I need to sum moments about a point to eliminate unknowns, then sum forces. That's equilibrium, the definition of. So here I have a beam spanning from A to B and then extending out to point C, which is just kind of hanging out there in space. Point A is at a it's going to be real annoying. Point A is a pin on the left, and point B in the middle has a roller. And as I say, point C is just hanging out in space. I have two kips equidistant between A and B, and a triangular distributed load between B and C, starting off at 400 pounds per foot at B and decreasing to 0 at C. So as I say, the first step is to draw a free body diagram. And I need to replace supports with forces. At A, I have a pin which resists X and Y, up and down, and horizontal motion. So I put these two forces at A, AY for the vertical, AX. I put my 2,000 pound load. I've got a 2-kip load, and I kind of got a discrepancy or an incompatibility there. I want to decide on one unit or another, so I'm going to say 2,000 pounds. I could easily say 0.4 kips per foot, but I'll choose to do it that way. At B, I have a roller, so all it provides is a vertical reaction. And then I need to deal with the distributed load and divide it into a resultant. Okay, it's a triangular load. I recommend treating these things as areas. The centroid of a triangle is where most of the area is concentrated, and that's towards the big end. So I can draw this little double arrow for the resultant, but I know exactly where it's located. It's 1/3 from the big end. So this span here is 8 feet, and so that distance there is 1/3 of 8, and that's 2.66 feet. My resultant force is just the area of that triangle, which is 1/2 base times height, 8 times 400. Do the math, and that's equal to 1,600 pounds. That gets everything I need to know. I might put in these dimensions, 4 feet and 4 feet and 8 feet down here. I've got a good free body diagram. I'll move on to the Cartesian step. Well, there's really nothing to do there. Everything's in the X and Y directions. There's no geometry to deal with. So I'm ready to proceed on to step 3, which is sum moments. And I want to choose a point to sum moments about to eliminate unknowns. So the logical one is to sum moments about point A, to eliminate AX and AY from the equation. So sum of moments is equal to 0. Sum of the moments I'm going to sum about point A. I need to show what my sign assumption. I'm going to assume that any moment about A that's counterclockwise is positive. I show that. And now I start writing my equations. Well, I don't have to deal with AX or AY because they intersect it. And I move to the left. They have a 0 distance to point A. I keep on going to the right, on my free body diagram. I come to this 2,000 pound force. I note that it's trying to rotate clockwise about point A. Therefore, it's negative by my sign assumption. Negative 2,000. All these are straight line forces times distances that create rotation. I have to have a force and a distance. The 2,000 is a y force. I need an x distance, which is 4. And as I said, my direction of rotation is clockwise, so it's negative. I come to by. It's trying to rotate the opposite direction, counterclockwise, so it's positive by y force times an x distance of 4 plus 4, or 8 feet. And then I get to Fr. It's trying to rotate clockwise, so it's negative. Fr is 1,600 pounds. Its x distance is, the distance from A to B is 8 feet. And from B to the resultant force is this 2.66 distance. And I've got all my straight line forces accounted for. There are no moments, so my equation's ready just to do the math on. I've got negative 2,000 times 4 is negative 8,000, plus by times 8, minus 1,600 times 8 plus 2.66 is 10.66. And so that number works out to be negative 17,066, repeating. Combine, do the math a little bit further, I get negative 25,066.6 plus by times 8. Got to be real careful with your negative signs because I can get negative answers which indicate opposite direction. I put the negative 25,066 on the other side of the equal sign, and I'm left with by times 8 is equal to positive 25,066. Divide both sides by 8, and I get that by is 25,066 divided by 8, or 3133.3 pounds. The positive sign for the answer means that my direction assumption of up was correct. So I show that direction for a complete answer, put a box around it, and that's by. Now I'm ready to use my sum of forces to solve for AX and AY. Well, I'll do the easy one first. Sum of forces in the X direction. Positive is to the right. It's equal to 0. Looking at my free body diagram, the only X force I have is that AX. Everything else is a Y force, so AX has got to be equal to 0. Finally, I do sum of forces in the Y direction. Positive is up. It's equal to 0. Look back at my free body diagram. I've got AY, which I don't know yet. Positive because I've assumed it up. Negative 2,000 because it's down. Positive BY, which is 3133. And then minus my FR, which is 1,600 pounds. Do the math. I get AY minus 466.6, repeating. It's equal to 0. Therefore, AY is equal to positive 466.6 pounds. The positive sign means my direction assumption of up was correct. Report it that way, put a box around it, and I've got it. You can use moments and some moments about point B and check your answers. A lot of these questions you can check your answers by doing it a slightly different way. So I've been talking to people about understanding how triangular distributed loads work and where that 1/3 is. So I've got a very similar problem that I'd like to look at, where I just reverse the direction of the distributed load, or the triangle. In this case, everything's the same, except for the triangle starts at B at 0 and slopes up to 400 pounds per foot at C. Therefore, my free body diagram looks like this. Remember, that's the first step. I've got AY, and I've got AX, and I've got BY. I've got the 2,000 pounds down here in the middle between A and B, 4 feet and 4 feet. And then I've got this same resultant force, in this case, or in both cases, it's 1/3 of the distance from the big end. In this case, that's the big end on the right, so I want to measure everything from the left, really, where the tip of the triangle is. So that distance is 2/3 of the base. So this is 2/3 of 8, or 5.33 feet. FR is still that 1/2, 8 times 400, 1,600 pounds. I've just reversed the direction of it. So there's a good free body diagram. Ready to do some calculations. Once again, I'm going to sum moments about point A to eliminate those two forces. Sum of the moments about A is equal to 0. Counterclockwise is positive. I've got, just ignore AX and AY, so I've got still creating clockwise rotation, so it's negative 2,000 times 4. These numbers are the same. Now I don't know what BY is. It's different. It's causing counterclockwise rotation, so it's positive BY times 8. And I've got FR creating clockwise rotation, so it's negative 1,600 is what FR is. Its Y distance, its X distance is now from A to B is 8 feet. From B to the force is 5.33. Add those two numbers up and I get 13.33 feet as the distance from FR to point A. I do the math. I've still got negative 8,000 here, plus BY times 8, minus 1,600 times 13.33 works out to be negative 21,333, repeating. Combine those terms, I get negative 29,333 plus BY times 8. Therefore, BY, take the negative 2933 to the other side of the equal sign. It's 2933 divided by 8. That works out to be 3666, repeating. Positive sign means my direction assumption of up was correct. Report it that way, put a box around it. I'm not going to mess with sum of forces in the x direction because we saw AX is equal to 0 by inspection. I've just got sum of forces in the y. Positive is up. It's equal to 0. I've got AY assumed up minus 2,000 plus BY, which is 3666, minus FR, which is 1,600. Combining all the terms, I get AY plus 66.6, repeating. Therefore, AY is equal to negative 66.6 pounds. The negative sign means this direction assumption, which I did was up, I assumed up, is really the opposite of that. That's what a negative sign means. My assumption of direction was opposite, was wrong. Put a box around it, and there's the answer.